much basics below CCR. Okay. So for example, in the first day we have discussed about alternating current and direct current. And the power, electrical power is in two different modes, like alternating current and direct current. And you know that whatever power is coming to your home, 220 volts, alternating current with single phase, probably required three phase also. Okay, not only single phase. But however, here in the classroom, you have 220 volts. That means whenever your voltage is 220 volts, okay, so it is single phase. But in fact, electricity was produced in three phases. Okay, and all those three phases carried out through all the power distribution system. And there are so many transformers in between. So what is that you need to know today? If there is a power generating station here, maybe hydro power plant, thermal power plant, wind power plant, there are so many types of power plants. So there are power plants. Okay, any type of power plant, you take any type of power plant. And the ultimate, their power output, which is coming, is in three phase, R by B. The phases are called R by B. Red, yellow, blue. The phases are called R by B. And also they need to have one more neutral, and the neutral, they just ground it there. Wherever they produce the power, the neutral, they just ground it there. So that wherever they want a neutral, from the ground connection they can take out. Okay, suppose say here we have a transformer. And it is giving you once again three phases and one neutral. And this neutral is brought from the ground connection. And these phases are directly connected. So the neutral from the power generating station need not to be carried to the distribution transformers, because the neutral is grounded here. Once again, wherever you want a neutral, you can take from the ground. So you don't have to carry another cable. That's where you always see the power distribution cables only with three wires. They are all phases, they are lives. Phase is also called in electrical distribution system live. That's where we always see L and N. Live and neutral. On the plex you always see L and N. Live and neutral. So these phases, they are also called as live wires. Okay? And neutral is nothing but at zero potential. Zero potential. Now here is a new term called potential. Zero potential. So with reference to this neutral, we always measure the voltage. So whatever voltage you measure, whatever pressure you measure, there is nothing but with respect to the neutral in alternating current power distribution. Okay? So if I say R phase is 230 volts, suppose say. That means you are measuring the voltage with respect to the neutral. So what you need to do, we brought another two more meters like this, because you can also practice that. What is that I say here, you can also practice. So here this particular meter has got measuring alternating voltage. There are two scales here. One is a 200 volts level, another is 600. So whenever you wanted to measure the voltage more than 200, you need to keep it in 600. Whenever you wanted to measure voltage, alternating current voltage, maybe 6 volts, 10 volts, 24 volt AC and all, then you need to go for 200 volts more, because you get points here, digital. Okay, for high voltage measurement like 230, 250 and all, you need to keep this in 600 volts. Okay, my dear friends. Now there are two probes. One is called as common one. That one I am talking about the neutral. You need to keep it this black one on the neutral, and then you take the positive, the phase one on any other phases to check what voltage is on what phase. And here, though the three-phase system has come into our school, but however, from three-phase, they just brought only one phase here. So, neutral anyway common all across the wiring, total is the building wiring, neutral is common. And then they just brought one phase here. So, whatever the voltage difference between that phase which is brought into this classroom to the neutral is the voltage what we have here in the class. Interesting? Maybe next class may not be the same voltage. Why? Because maybe to the next room the same neutral is carried, but however may not be the red phase. They wired in such a way the Y phase might be going into the next room. So if you check the voltage here, if it is 220, if you go and check there, it may not be 220 because it might be in some other phase. The neutral voltage difference between neutral and the phase is 230 suppose there. Then you can come back and ask me, sir, why is that here it is 220, there it is 230? Who is boosting? No, it's not question of boosting. Maybe they are on different phase. Okay, so there is a difference between phase to phase. Though they give a transformer, electrical department, all the three phases are equally given, but however, because of more load or less load connected on that particular phases, the voltages might be slightly different. Okay, that's where we see the difference here also. So, at a particular ground level where three phases have come, there we can see neutral to all the phases, what is the voltage, what is the difference, and we can note down R phase is this volt, Y phase is this phase. Then whenever you go to any classroom and check that, if suppose say there you found 230, that means R phase, because you already noted there it is, then you can understand, oh, R phase is connected to this row. Okay, there in the main meter area, if it is 220 on Y phase, if at all anywhere you are finding phase voltage 220 on the room, then you can feel, oh, this room is connected to Y yellow phase wire. Likewise, you can have a proper thorough understanding about that three phase system. Okay, you got it? You understand now?
Yeah.
Now, I have another issue. As I told you, that this is power generating station. Okay, power station. This is power station. Okay. Now, my interesting thing is that I told you, this can be a hydro power plant, thermal power plant, nuclear power plant, wind power plant, whatever power plant it is power plant. And all the power plants are producing output voltages, and that is called national grid. Everyone has to get connected to national grid. Okay, national grid is at 220 kilovolts, 220 kilovolts. So, in fact, in the power generating station, internal alternators here inside might be producing power at 11 kilovolts. Okay, 11 kilovolts. That 11 kilovolt is stepped up by a stepped up transformer there in the power generating station itself to 220 kilovolts, because they have to get connected to all national. So why they have stepped up to raise the voltage from 11 to 220, I will tell you later. Okay, but right now, just imagine that all the national grid is connected at 220 kilovolt. Okay, for example, and all these 220 kilovolts, very big tower power cables are going all across the, okay, and again we have regional grids, okay, and then statewide grids. And now finally what I wanted to tell you from this most interesting thing is that all these 220 kilovolt, they raised the voltage level of the power generating station to 220 kilovolts, and from the 220 kilovolts, suppose say this is 220 kilovolts kV, and then they will be going like this, and somewhere they will be stepping down to 132. Okay, 220 kilovolt step down to 132 kilovolts. Okay, and somewhere after that there will be further step down somewhere by 132 kV to 66 kV. Okay, and then once again 66 kV might be going to further step down to 33 kV. And these 33 kV might be going to some other substation called 66 kV by 33 kV. Oh, this is now 33 kV by 11 kV. Now this is 33 kV by 11 kV. So these 11 kVs are going all across your streets and to villages. All 11 kVs are going all across the place. Now I tell you, here is one important point. Those are 220 kV grid is there. For that grid there are so many substations. They are called 132 kV substations. For every of that 132 kV substation, there are many 66 kV substations, and for every 132. And once again, when they get like that 66 kV substation, there will be so many 33 kV substations connected to 66 kV substation. And there are so many 11 kV substations connected to 33 kV substation. And here in Bomur, Rajahmundry Bomur, you have this substation. So Rajahmundry Bomur, you receive 220 kilovolts and you get 132. And there in the Bomur, they have here immediately another 66 also, step down to 66 also, and also 132. See, 220 comes to the Bomur and that gets divided 3 for 132. And from one particular transformer, they have 66 to feed 66 to Rajahmundry, because there are 3 or 4 66 by 32 kV substations are there in Rajahmundry. 5 or 6 are there. And again from 33 to 11 in Rajahmundry there are 20. And every 33 by 11 kilovolt substation is feeding to near about 24 11 kV feeders. Every substation of 11 kilovolt substation, 33 kV by 11 kV substation, they have feeders, 11 kV feeders. So every substation has got some 15-20 feeders. So every feeder will be feeding to entire one area. So all 11 kVs will be going. Finally, what I mean to say, the transformers what we see on the roads are getting input voltage 11 kV. Okay, now the transformers whatever we have on the streets, so we will be receiving 11 kV and then we will be getting out 220 volts. Phase, single phase, okay, phase to neutral. Similarly, we will be getting 415 volts, 3 phase. So now I will just remove this drawing.
Sir, I have it out.
And then now I have 3 phases coming, 11 kV phases. Now here is my transformer, which is on the road side, okay? And what happens is that I get 3 phases, 11 kV, 11 kV, 11 kV, R by B. And this is my 11 kV by, see 3 phases have come, R by B and neutral. And in fact, this is phase to neutral is 220 volts, 220 volts, 220 volts, okay? Neutral to any of the phase if you measure, then the voltage is going to be 220. But now here is a question, if you measure between phase to phase is what? Phase to neutral is 220, phase to phase is 440. So, there are some equipments like 3-phase motor. You have a 3-phase motor. You don't connect there a neutral. Directly all 3 phases are connected. That means that is working on 440 volts. You don't need neutral there. So, whenever we wanted to drive high power equipments, then like big welding machines or big motors, we don't use neutral there. Because if you use neutral there, that means what happens, only 220 volts you get. So on 220 volt they draw more currents. That's why what they do, instead of using neutral, they use all 3 phase. They are called 3-phase loads. That motor itself is called 3-phase load. That's not a single phase load. That is 3-phase load. So 3-phase load don't require the neutral. But however, the operating voltage of the 3-phase load is going to be 415 to 440. Okay, my dear friends? But however, single phase loads will be working in between 220 to maximum 250. That's it. Okay, my dear friends? So, the output voltage of this transformer is proportional to the input voltage. If it is less, the voltage will go down. If it is more, coming from the 33 kV transformer, the secondary voltages are going up. Okay, that's variation. The voltage fluctuation because of the input voltages and Another important point that load putting onto this secondary of the transformer. If the transformer is capable of handling only 100 kilowatt and people are putting more load on those phases, the voltage drops drastically. So we have to calculate what is the capacity of the transformer, what load must be put, and what is the load people are asking, and what is the transformer we put. All these things are going to be designed by electrical department, and they have to manage the requirement and the supply, whatnot. It's a day-to-day base calculation for them. Okay. Now, just I dealt with this kind of three-phase system. Now I'm going to just introduce, and it is just basic part what I talked about three-phase, the way we produce the power, the way we distribute the power, the way we just receive the power is till now the introduction. Okay. Now I'm going to talk to you another important point, basically which is what I thought I'm going to give an extra part. Okay. The extra part is a transformer. Transformer. Without this, because that day in the first class someone asked me how to convert AC to DC. So, what is a transformer here? I am going to talk to you. Suppose say, okay. Okay, my dear friends. And all this portion is the core.
You should be placing inside the course.
This is core, iron core, laminated iron core, not simple iron piece. It is a piece of laminations got together. It is a laminated iron core, on which we have two coils placed. One is here, the other is there. Just understand, there are more number of turns and less number of turns. Okay, and it is thicker and it is thinner. Okay, so again more number of turns on this side, less number of turns that side. But however, the diameter of that secondary winding is much more than the primary winding, the diameter. And the wire what we have used for turning this coil, making this coil, is enamel insulated copper wire. That means if you see the wire, it is not a bare copper. It is already insulated. A layer of enamel is already coated on the copper. If you touch that, whatever power is going, you don't get shocking because it is already insulated. But the thickness of the insulation is so low, but even then it works as an insulation. Like the plastic insulation what we have on the cable. Similarly, on this cable also, we have that enamel insulation. Okay, whenever we want to solder this particular wires and all, we have to clean the copper, for removing the enamel, and then you can solder. Okay, now why is that I am talking about? Say here, you said what is a 9 volt battery and all we are handling, right? The projects you wanted to use them on 9 volt DC. Yes or no? For using them 9 volt DC, you need 9 volt AC. So, but however in your home, you get 9 volt AC? You don't get. Yes sir, what is the voltage you get here? 220 volts. So we need to convert, that is 220 volts AC or DC?
AC.
But we need to convert into
DC.
So we need, ultimately what we need is the 9 volt DC. But we have 220 volts AC. So what this transformer is going to do, suppose say the primary of this transformer is 220 volt AC. Primary. We designed that particular number of turns like that, and also we have designed number of turns on the secondary so that the output is 9 volt AC. So transformer is doing what?
It is
Just stepping down the voltage. It's not converting AC to DC. It is only converting high voltage to low voltage or low voltage to high voltage. Vice versa, it is handling voltage and current. Okay, power is not handled, it's only handling the voltage and current. Okay, now, in fact this AC, I need to convert to DC. Then only your circuits will work. If you connect your circuits on this AC, they don't work. Because we need DC for all the electronic circuits. What transformer does is, it only handles power at one level to the power at other level. That means power from primary to the power to the secondary. Okay. Now the important thing is that if I say this is a 100 watts transformer, for example, the power handling capacity of this transformer is what? 100 watts. Okay. So the power handling capacity of this transformer is, suppose if I say 100 watts. Then in that case, you know for sure, I already well explained that transformers doesn't work for DC, they only work for AC. Why is a question later to be discussed and asked. Right now, see, as you know that P is equal to V into I, is it not? And if that is the case, what is the given input voltage here? Given input voltage is what? 220. As a maximum I told you up to 250, right? Now, P is also known to you that this transformer is going to handle 100 watts. So, 100 watts is equal to maximum 250 volts into I. So, what is the current going to be there in this primary circuit? The current what is entering into this particular primary winding?
20.
No, that is the voltage given at the primary. Maximum it can go up to 250 also. So, but you know for sure that my transformer is going to handle only 100 watts. In that case, 100 watts is equal to 250 into I. And so, to handle the power at 100 watts, my primary current is going to be how much? I is equal to what? 100 by? 100 by? 250 volts, AC, maximum volts. So, tell me what is the answer for this? 100 watts by 250?
0.4 ampere.
0.4 amps, okay? So, to make sure that my transformer to handle 100 watts at primary voltage at 250, which is not in my hands, because the AC voltage is coming from someone else, the power supplying company is supplying me at 250 volts, to handle 100 watts power, so my primary winding is pulling how much current here?
0.4 ampere.
0.4 ampere. Yes? Now, I designed this transformer in such a way that my output voltage, instead of 9 volts, for your mathematics easy, what is that I did? I just make it to 10 volts. What is that? 1 volt. Okay? So I just made the design in such a way, whenever you give 250 volts here at primary, I get here 10 volts. And also, because I told you, transformer is not going to handle, boosting the power. Transformer is not going to boost the power. It keeps the power as it is from primary to the secondary. That means secondary power also is going to be 100 watts. P here also is 100 watts. It is not going to boost the power in watts. It is only handling the voltage and current. It is not improving the power or decreasing the power. Okay, my dear friends, okay? Just assume that the efficiency of this transformer is 100%. That means it is not wasting power, it is not raising the power. Okay, the same power is kept constant from primary to the secondary. But however, we made the design of the transformer because you need for all of your circuits 9 volt, no? That's where whatever voltage I have here in primary from coming from utility line, that same one I am stepping down to 10 volts. So that way I made my windings. The number of turns on primary, number of turns on secondary, I designed in such a way, the moment you charge this transformer, that means you just connect these two wires to the 250 volts line, that's it. Then after that you must get here 0 to 10 volts. So that is step down, the voltage is step down, yes or no? But I wanted to find out, though I have 0 to 10 volts here now, readily whenever you measure the voltage with your multimeter, 0 to 10 volts. But what is the maximum current I can pull out from this secondary of the transformer?
10 volts.
Huh?
10 volts.
No, they are 10 volts because the moment you charge this transformer, that 0 10 volts has come already now. At that potential, what is the maximum current you can pull out is the 100 watts power. Power is 100 watts. So what is current going to the maximum current is going to be from this transformer is nothing but, so once again I is equal to P by V. Tell me, I is equal to?
V by V.
I is equal to?
V by V.
So now, what is your P here?
100 by 10.
Now 10. What is the current you can?
10 ampere.
0.1. Sorry, 10 ampere.
10 ampere current you can pull. So, secondary side, because of the low voltage, the current went up. You can pull more amperes. Okay? And on the primary side, because of the high voltage, the current came down to 0.4. But handling 100 watts on the primary, similarly, handling 100 watts on the secondary side also. We are not increasing or decreasing the power at all. But what is the gain we have here? We are only manipulating the product of voltage current at primary level to the secondary level. Because you yourself asked me, sir, I wanted to make all my projects work on 9 volt DC. Instead, I don't want to use the batteries. I have 220 volt AC. Give me a way where I can do some modification. Based on the modification, I can use all my projects from direct 220 volts. So, what you need to have? A transformer. Connect to the 250 volts. And then secondary will be 9 volts or 10 volts, whatever. Okay, my dear friends? Now, this is still AC. The transformer is not going to convert to DC. So, transformer is doing what? It is only stepping down the voltage. Less number of turns on secondary and more number of turns on primary. And another question, the primary wire is so thin, but the secondary wire is so thick. As I told you, resistance and current are inversely proportional. Here you need more currents on secondary, and the cross-sectional area must be more. Otherwise the currents cannot be delivered because of more amperes. Because you have reduced the voltage so that you can have more amperes. So for which to carry those many more amperes, the wire must be more thicker. So that resistance comes down. That's what we have discussed in the first class. Interesting now? Okay, that's one thing. That means whenever you wanted to check your transformer, underline this very important point I am talking now. To check the transformer, I will give you the transformer right now in front of you. I brought 1 or 2 transformers for you, right? And every of these transformers will have 2 windings. One is primary winding, other is secondary winding. Yes or no? But both windings are wound on the same core. They are not physically connected, my dear friends. The electrical connection is not there between primary to secondary. Yes or no? Are you following me? No physical connection. That means if you give 220 volts here, you don't get shock here. That same 220 is not connected. But however, due to magnetic coupling between these 2 windings, because the magnetic energy is passing through this core. This is the laminated iron core. So through this laminated iron core, the magnetic energy is passing through. So because of the magnetic energy is passing through, you get mutual induction here, microfarads. And where, based on the number of turns, the mutual induced voltage is induced here at the secondary. That's where you are getting secondary voltage. So this voltage is not directly coming out here. So because the core is there in this coil, the electromagnetic force is produced, and then that is circulating in the core like this. Because there is another winding you wound on the same core, and there is a flux cut there. That's where the induced EMF is induced in the coil. Based on the number of turns, the voltage is 10 or 9 whatever. Interesting, my dear friends. So there is no physical connection between primary winding and secondary winding. That's where you can also see in this transformer, there are 2 different coils placed on the same iron core. So you will be giving power to one coil and taking power from the other coil. So whichever coil you are connecting the input power, that is called primary power, primary coil. Okay, and from where you are taking the power out is going to be secondary. But however, in between primary and secondary, remember, because more number of turns. If I ask you a question, how do I identify primary winding and the secondary winding of this transformer? Because if you go to market and you buy a transformer, it is my biggest childhood question in 6th class. I brought a transformer, I told you, remember, like when he said that a transformer 100 rupees every, I could able to buy the transformer, but there are 4 wires coming out of the transformer. I don't know which wire to be connected to what, I don't know. Where is input, where is output, I don't know. Which is primary and which is the secondary, I don't know. Okay, so I took near about weekdays to understand that. Finally, with this drawing, for you it is just 2 minutes job because there are more number of turns here. It is thinner, but more number of turns. You know, when it is thinner, the resistance is high, and more number of turns, that means the length is more, and you know, as per our first day's class, resistance is directly proportional to, and also because it is thinner, resistance is more, and because of the length, the resistance is more. So you just measure the resistance of these two windings. You measure the resistance between this coil and also measure the resistance of this coil. Which one will be more? This resistance is more or this resistance is more? This one is more. So whenever you find the resistance between these two, that winding is more, that is primary winding, to which you need to connect 220 volts. You understand? And the resistance so less is going to be secondary, from where you are taking low voltage high currents. Okay, my dear friends, this is the way you can understand which is primary and which is secondary. You understand? So the low high resistance, usually I tell you, whenever you buy a transformer like this for all your small gadgets, okay, this small transformer this side and all, maximum 100 watts of transformer, less than 100, power handling less than 100 watts transformers and all. Usually the primary resistance is going to be in the order of 600 to 1200 ohms. This is my practical experience. 600 to 1200 or maximum 1800 in between. Okay. And here it is going to be somewhere between 2 to 10 ohms. So whenever you find the resistance, if you measure the resistance of these two coils, if suppose one is showing in the order of hundreds of ohms and one is showing only in the few tens of ohms, then which is secondary and which is the primary? Tell me fast.
Which are more is primary and which are less is secondary.
Yes. Now, will you connect 220 volts AC incoming to the primary or secondary? Okay. So from secondary you can take out. Okay. Now you understand how to convert high voltage to low voltage first? AC, of course, AC, not DC. Okay. Now we shall discuss next 5 minutes about converting AC to DC. Now I don't have to explain how to convert AC to AC because it is sure now we brought high voltage AC to low voltage AC. So this low voltage AC, if you touch with hand under, it's not going to shock. Here it is going to shock because the potential difference is high, so that your body allows more current at that potential, so you feel shocked. But however, here also current is flowing, but little because of low pressure, low voltage, low pressure. So you don't really feel hazardous, but however it is dangerous here this side, okay? Because high voltage, high potential. 220 is good enough to pass, allow currents to your body. If the circuit is close to your bare foot and all, okay? That's the floor wet and all. But however in United States, their potential difference between neutral and phase is 110. They reduce even half up to our Indian power supply. And also their homes are well carpeted, so that maximum insulation is taken care. That's why in United States, by mistake, if someone, that's where all their power outlets in United States are not switch control. They don't use any switch. Suppose if you want to use a vacuum cleaner, what you need to do, just take your vacuum cleaner and put into that 110 outlet. There is no switch there. Directly you control with your vacuum cleaner. Okay, and they don't care much because of course it's low voltage for 10 volts, less than half the voltage of that. But that also gives little mild shock, but still the return path is not closed so easily the way it happens in India, because here everywhere wet floors and directly on the connected with the earth and all. But there their houses are built with wood, and then again inside the house all carpets. So insulation is high there. That's where the live 110 volts is not really getting passed through your bodies, and also you are not much in risk there. But of course, there also if you touch live 110 to the neutral, then the current passes through you, and then hazardous it is going to be. But usually in India, only one wire is getting connected to you, and other connection is taking place through your bodies are connecting to the wet floors and all. That's where you are getting more shocks and all. Now you got it? Now shall I remove this, my dear friends? You understand this drawing? Well, it's good, interesting?
Yes.
Okay. So here in this drawing, the most secret is power remains same. My dear friends, we haven't boosted the power. That's where I wanted to tell you, as you are my students, the secret. Energy neither be created nor be destroyed. It only changes from one
No, one.
Form to
form to the other
Right.
form. Okay, my dear friends? Similarly, here in transformers also remember that electrical energy in the watts power, we are not going to boost up. Lot of people think that mistake by students, lot of students give me wrong answer. So transformer boost the power. No, it cannot. Give common mistake, the basic mistake what they are doing is that they are thinking that some additional device can boost the power. No additional. We all know that energy neither be created nor be destroyed. Okay. So rest of the items what we have developed intermediately to change its form to the other, to handle its voltage level to one level to the other, and all we have raised all this, developed all these gadgets like transformers and all. Okay, my dear friends. Now let me go to another device called rectifier. Why do I need rectifier? To convert AC to DC. Okay, so here is my box. This is called rectifier. So if I give AC input, it gives me DC output. Whenever I say DC, it's going to be plus minus. And whenever I say input AC, it's going to be phase node. Okay, or we symbolically show AC input like this. Whenever I mention like means this is alternating current, that is nothing but AC. Okay, so this is rectifier, this is rectifier. So what this rectifier is doing, it is converting power electrical energy from the form AC form to DC form. So as we have seen earlier that alternating current follows a sine wave, and however in direct current the current always flows. Interesting, you got this much, you got it now? Rectifiers. So one is the off-wave rectifier. The other is full wave rectifier. I am saying wave. So this is the wave. So from this we are using only off cycle in off wave rectifier. In full wave rectifier we are using full cycle. And again in full wave rectifier there are two categories. One is center tapped category, other is bridge category. So the full wave rectifiers, we have two different rectifiers. One is center tapped. Rectifier, other is full bridge rectifier. Bridge rectifier. Okay, so what is this off wave, what is this full wave, center tapped and bridge? It's important, okay, yes or no? So for which, what is that we are going to talk about? Suppose I told you we have a transformer. Yes? We have a transformer, primary and secondary, 230 volts and 9 volts AC here. It is 9 volts AC. And here it is 230 volts AC. And anyway neutral. And now, the moment you switch on your line and neutral, 220 volts here, you get here AC 9 volts. Now, if I have a diode here, one simple diode, in the third project, what I gave the black one, that one and 4003 or 7 whatever, okay? So if you use that one, silicon diode, that's it. After that, here this is 9 volts DC. But half wave rectifier. It is not totally utilizing the full sine wave. Only half the sine wave it is using. So efficiency of this rectifier, now you are getting 9 volts DC plus and this is minus. So instead of your 9 volt battery, if you use this, that's it, and that will work. But however, while doing its rectification process, AC to DC conversion, there are still little AC content is still leaking here. Because of this, your some electronic circuits might produce some noise. To avoid that, we have a filter capacitor. So this filter capacitor will filter the leaky AC currents which are coming here or grounded here, because this capacitor is acting short circuit for AC currents and That means whatever AC component is present here after the diode also is getting grounded. So output is pure, little pure, better pure, comparatively than here, without the capacitor, to the capacitor, the output is better, the pure, little more pure. But still, as a half-wave rectifier, it is not that pure, because efficiency is less, only less than 50%, less than 50%. Efficiency is less than 50%. That means if you are using here 100 watts, you will be getting only 48, 50 watts only, because of single wave, half-wave rectification. Okay? So, what is the best alternative? But for simple, it is very simple, no? It is very simple. For which we have a little modification. Primary winding 0 to 50 volts, and transformer lamination, iron laminations, and then we have secondary winding. But here, this is center 0. So 9 volts AC, 9 volts AC, 230 volts AC. Okay, my dear friends? 0. That means 0 to 9 are repeated 2 windings. So center is 0. That means it is 0 to 18 volts winding. In the center we have taken another tap, so 0, 9, 0. So whenever you wanted to have this kind of transformer, you have to go and ask market, okay, 235, 909. What is that you need to ask them? Whenever you wanted to buy a transformer like this, you need to ask them 909. So when you have this kind of center tap 909 transformer, then you connect a diode here, the same diode, and another diode here, and 2 cathodes in short circuit, and you will have here plus 9 volt DC, and the center one is the negative for the same. And for filter, connect this. So this is full wave center tap, not half wave, full wave. Good rectification, better purity, okay, and efficient one compared to the half wave. It is much efficient one. Reasonably good, it works like nice. I have used so many times this one in my childhood. Okay, almost up to 7th class, lot of projects were used by me with this. And after this, another very good, interesting, much better than this model, we have another model called bridge model, full wave bridge. So we have a transformer here, and lamination, and so these days you get a bridge. There are 4 diodes inside, not 2 diodes, it's 4 diodes inside, and on the bridge there are 2 symbols, AC symbol. There you connect your 0 and 9, okay, and then from here you get output plus and minus. There are 4 diodes inside. Instead of 2, there are 4. So we connect one part of filter capacitor. And here it is going to be plus 9. Plus 9 DC. Tell me, it is AC or DC? Here it is up to here it is AC. 250 volts AC. Okay? Happy or not? So this is called bridge rectifier because you are using a bridge. You can buy this bridge. It will have 4 pins. 2 pins for connecting your transformer secondary, 2 pins for taking out DC output. Okay? Happy about all this? So this is bridge rectifier, very efficient than even center tap, center 01, and you don't require more winding here, and you don't require 909 transformer. 09 transformer can be connected to a bridge, and then the bridge output is plus minus. You don't have to handle the number of diodes. Already internally soldered in the box, a small box. That's called bridge. Okay? So, but you need to know, whenever you go to shop and ask bridge, you need to ask, then immediately the shopkeeper will ask you, what is ampere rating? Because bridges are there for you 10 rupees, 50 rupees, 100 rupees, 1000 rupees, 10,000 rupees. There are so many bridges. Okay? Immediately, what is the question he will ask you for the bridge? He will ask you what is the ampere rating. Okay, I thought you will ask me what are the specifications for buying the bridge. Then I thought I will tell you this. I'm waiting for your question about that. Okay, next. About the same transformer also, if you go to your shop and if you tell him, hey, give me primary 230, secondary 9 volts. Then he will ask you, 909 or 09? He will tell, what? Tell me. Suppose if you tell 909, just for 2 diodes to be put on that and you wanted to make out DC, right? Yes or no? And immediately you will ask, what is the current?
230.
That is voltage, man. That is voltage. Already you told him. 225 9 volts transformer you told him. The next question he will ask you, what is the current? So you will have to tell the current. Then only he will give you. Otherwise, see, a transformer like this. This is 350 milliampere transformer. And I also brought 500 milliamps. I think I also brought 1 ampere, 1000 milliampere. Okay, likewise, transformer size will go by the current rating. If you want more and more current, the size of the transformer will go up. Okay, my dear friends? Are you following what I am saying? So, what makes the transformer to be bigger by more and more size? Because your amperes. Why, if you want more amperes, why the size of the transformer is going to be big? Is a question for you. Think about it, okay? Okay, think about that. Now you understand about conversion AC to DC and all, fine. Another most important point, the most interesting point for you guys to think about, may not, I don't think I will be covering today in this class. Okay, one important point. Now here, listen, the most interesting part what I have identified in my childhood, when the voltage is going up from primary, because this is not my hand, and the voltage can go down, in India it's happening, the primary voltage can be anywhere between 170 to 250 or 260 also sometimes. It is changing so badly in India, but in the United States I never saw. If they say that 110 volts, only plus or minus 1 volt it is there going there and here. But in India, they are supposed to give 230 volts. But however, it is happening whenever sometimes we might find anywhere between 170 to 260, anywhere. So much of huge variation. Because of which the secondary voltages are also varying. Because of which the DC voltages are also varying. So because of which your circuits may not be functioning properly. Because they are designed for the best regulated voltage, constant voltages, because they are all electronics. We have designed them to particular reference voltages. There are so many voltages like reference voltages. So the reference voltage is varying means the functionality of the circuit is varying. So ultimately the output of the circuit is varying. The performance is mismatching. Lot of dangerous things can happen. Instead of in train track system, you suppose say, instead of red, it is yellow because of the low voltage variation. Some other IC will trigger and then the output is yellow, then driver will pull. That's it. If we cross the red signal, that's it. What other danger can happen? You don't know. Yes or no? Similarly, lot many mistakes can happen. So to avoid all that, we need regulated voltage, regulated power system. That is called RPS. Regulated power supplies. RPS is regulated power supplies. So what happens in regulated power supplies? Irrespective of your input voltage variations, the output is kept constant. Output is maintained constant. Irrespective of your input voltage variations. How nice is that? So how it happens, how it works. Interesting? So one example I will show you here. After that you can learn many. Okay, one example as I present to you guys, my batch guys, I wanted to give one example. Very simple. So from here we have a regulator IC called 7809. So it has got 3 pins. One is input pin, one is output pin, one is ground. Okay, this is the output. So we can have one more filter capacitor. So once you use this 7809, That's it. Your output voltage is always 9 volts. It is not going to be increased. Okay? And not going to be decreased. But one condition. The input voltage always the input voltage must be high than the output voltage. Or what is output voltage you want? 9 volts. So for which I am using 9 volt regulator. The 7809 is 9 volt regulator. So I need at least 3 volts more at input. That means what is the voltage here I need?
12.
So for which? What is the voltage I need here?
AC.
12 volts
AC.
AC. The transformer instead of 09, you need to have 12 volts AC transformer. Or even 15 volts AC transformer. I don't have problem. Whenever you are using 15 volts, here also it is going to be 15 volts DC. But however, it is the 15 volt DC is more than required voltage. So rest of voltage is grounded. So output is maintained 9 volts. So even if this voltage goes to 170 also, here it is still more than 9 volts. That's where the output is 9 volts. Even if it is more like up to, instead of 220, if it is 260, here instead of 15, it will be 18. Even then 18, it can step down to 9 and it maintains high. And maintains 9 volt constant. So that is interesting regulator IC, very low cost. It's I think around 12 rupees or something like that. 15 rupees max. But still it does lot of activity. Right from your input, 170 to 60, whatever it is, but your output voltage is 9 volt constant. Okay, my dear friends, yes or no? So all your projects will very nicely work if you build this power supply, a regulated power supply for 9 volts constant DC. You build a project and use that output plus minus to all your projects. Instead of 9 volt our battery connection socket, you just parallelly solder another 2 wires and the same connections on the board and connect to this. They will work. Yes or no? Happily they will work without botheration of any other voltage variation in the input side. Otherwise, if you don't design this way, Vinita may say that's your fine. When I go and use my project at my home, it's working, sir. But when I go to my grandparents' house, it's not working, sir. Why? Because the voltage might be there 190. Here in your home, it is 230. At 230, she designed all transformer and 9 volts and all perfectly working. But when she go and grandparents house here at 190, output is around at 7 volts. Then your circuit may not be properly working. So here, if you use this kind of regulated power supply, you go to your grandparents or your cousins or your friends, wherever, you need not to bother. It works like that. Okay, my dear friends, yes or no? And I have another important one question here. What is that question, I don't have electrical power connection. Yesterday, when election is going on, right? So a lot of time power got disturbed. So they are finding problem with the machines. Like similarly, whenever you wanted to demonstrate your project, whatever you make, right? You already made few projects, yes or no? You wanted to happily demonstrate to all of your friends or someone wherever. Yes or no? So, you have the same, this setup is like this. But if you have your 12 volt battery, then where is the battery? Show me. 12 volts battery. 12 volts battery. And you have this one, but however your projects are designed for 9 volts, right? And use the same setup and connect to this plus minus. This is DC. So this is DC fed into the regulator input and automatically output is regulated output at 9 volts. So you carry this one with your regulated, that is the regulator power supply, small, this item, and then connect to your projects and make sure that they work very well. This you can charge it. Okay, my dear friend, throughout night you can charge it, throughout day you can use it for your, and what is the power rating of this battery? That's important. Now this is where this special class has come to you. You must thank to me. Now Prem here. Now Prem always feel that he is but advanced. He thinks that before me, he learned lot many things. I handle these guys of guys, lakhs of children all across the state. They are interested in learning lot many things, but neglecting the basic. That's where this special class is developed. Of course, I appreciate Prem to feel myself that he decided to take this course. Okay, though he did so much in robotics and now this is the question goes to him. Prem, what is the power of this battery? Now see answers how they will come.
6 volt and
See, what is that he said? What is that he said? 6 volt he said. But this is the common most mistake taking place. Okay? So 6 volt is not power. That's voltage. But what is the power of this battery? No, wrong. That's only amperes is talking. This is the mistake happening. I'm asking the power because suppose say, if we don't know the power of this battery, what the mistake is happening, my dear friends? I have a circuit, okay, which requires 1 watt. And I wanted to make sure with battery, my project will work for 10 hours. So don't you think that you need to have a battery more than 10 watts power? Because I need electrical energy. This is my reservoir, energy reservoir. So I need to make sure this battery has got more than my required power. Otherwise, how can I make sure that I can go around wherever I want? Like suppose take my video camera. I wanted to record it for this entire class for 3 hours. So don't you think that I need to charge the battery and keep the power inside the battery that which can make my camera work for more than 3 hours? Otherwise, you are missing the content. Yes or no, my dear friend? So this is the question, homework question. Already explained in the first class. Okay, that's where I'm asking you to do this homework, okay? Think about it. If I tell in 1 minute, I can finish up it, but it's not going to help you. Okay, tell me what is the power of this battery?
60 watt.
Of course. Good answer. Big hand to our Ruthik. Good. Ruthik, come here. How you have calculated this power of this box? Power of this box. I don't say battery. Power of this box.
Because power is equal to V into I formulas.
Oh yes, P is equal to V into I. So whatever our brain said 6 volt and then 10 amperes, then what these guys did, we multiplied the both. That means it has got a power of storing, it has got capacity of storing electrical energy of 60 watts. Suppose say I connect a bulb here, 1 watt bulb, 6 volt 1 watt bulb, a backlight bulb, 6 volt and 1 watt. That means the power consumption of the bulb is 1 watt. But it works, it is designed that it works on only 6 volt. If you connect on 24 volts or 220 volts, it will get spoiled. So it is designed, the filament is designed to spend electrical energy of 1 watt at 6 volt. If I connect that particular 1 watt bulb of 6 volt to the 6 volt battery and having 60 watts loaded in the battery, how many hours the bulb work on this battery is a calculation question to you. Tell me. The bulb is consuming 1 watt. Okay, and the watts of this battery, electrical energy stored in the box, this battery is 60 watts. Then how many hours my bulb can work on this battery? 60 watts is there here. I need only 1 watt for my bulb. How many hours this battery can support to my 1 watt bulb? Because 60 watt energy is there. 60 hours. So simple. That means here whatever he said, the 6 volt and 10 ampere is nothing but you need to understand is the ampere current rating ampere is along with the ampere there is something else also written on the battery, the ampere hour. So he did not set that about the ampere hour. So we have neglected all. Ultimately we are missing the calculation with hours. So here it is current ampere hour. In the batteries we always need to talk about the ampere hours. Okay? In our inverter batteries are ampere hours. Okay? Not that simple amperes. Okay? Amperes we only just measure in the circuit. But however when it comes to a point like storing the energy and all, we always talk about with reference to the time. Okay? Amperes with reference to the time. Amperes. That's a different batteries class we will discuss later. Now it's going to out of. Okay? Thank you. Okay, keep it. Keep it. Okay? Now where we are now? We have finished AC to DC and also regulation. We have talked about half wave, full wave, and then bridge rectifiers, and then regulated power supplies, keeping the 9 volt. And there can be many more. One more most important point I want to touch for just 30 seconds is regulated power supply. We had talked about 7809 regulator IC. But these days, we don't use transformer and then rectifier and then regulator. No, we don't use all this. We directly use another power supply system called SMPS. For every small required power, we use SMPS, switch mode power supplies. SMPS is what? Switch mode power supply. Because they are very highly efficient. Switch mode power supplies are very highly efficient and intelligent fellows, and they work for wide range of operations. So very intelligent, very fast, okay, and low in weight as well, efficient as well. So that's why these days, almost last 15 years, I am only using SMPS power supplies. Transformers and then rectifiers and then regulator. This is okay, little task. But for many of these days, we get SMPS for any of your voltage, any of your currents, any of your power ratings. So easily at very low cost they are available. So why can't you use, when switch mode power supply is widely developed for wide applications, why can't we use switch mode power supply? Okay. And AC to DC we talked about. Okay. And also we can talk about DC to DC. They are called DC-DC converters. Very important. Because solar energy, when you wanted to work with solar energy, you need to know about DC to DC conversion. Because solar energy coming from photovoltaic, the solar plates, when the light rays are falling on the solar plate and the watt is the output you are getting electrical energy is DC. So that DC, again you are controlling into DC to charge the batteries and all. So there intermediately you are using a circuit called solar charge control units, CCUs, solar charge control units. So they are nothing but DC to DC converters. Okay, and after we will convert DC to AC in inverters. Little extra thing I wanted to talk about. Without which it is not going to be much thrilling for you. Okay.